Hello. So my talk today is on DevOps secrets management. This is going to be mostly cloud-centric, but not exclusively, and also loosely focusing on DevOps and application secrets and less of the IT-centric secrets like Active Directory. We're also not going to be talking about SSO or federation and so on. So I'm Murriel McCabe. This is my garden, which I'm super obsessed with, in addition to just generally making things and community. And I've been working in the systems admin and operations space for quite some time. So tell me, can you keep a secret? Can you share a secret? But also, more importantly, can your systems keep and share secrets? So before we start, what exactly are secrets? So there are a few different categories. And to start, there are some personal and team secrets. Everything from your logins, your keys, and in case anyone was wondering, no actual private keys were harmed or disclosed in the making of this talk. You have your certificates, your configs, and so on. And you have ones that are exclusive to you that you don't want to share, as well as the ones that are shared across the team. So in addition to that, you have system secrets, and systems generally encompasses several things, from your servers to services, all the way up through serverless and things like IoT. So imagine a world where your vehicle is getting over-the-air updates and authenticating to a backend server with a credential that is embedded into your car's onboard system. So that sounds like something that might be important to keep secure. Okay, so why is this important? I don't think anybody will argue that security is something that is critical to organizations now. The cost of leaks can involve everything from loss of user data, user confidence, ransomware, crypto mining, and so on. And as everyone probably knows, there have been a ton of very high-profile breaches due to improperly secured secrets and a number of other vectors. So moving on to that, just some of the different vectors for compromise. This can go from credentials that are improperly stored and published, all the way up through your internal threats, like ex-employees or internal employees, unauthorized access to systems. There are several methods that your secrets can actually get out there into the wild or discovered. So let's dream for a second. Close your eyes with me and dream of a paradise where we're all running environments with consistent tooling, the same config management tools, standard templates, no legacy secrets committed. All of your systems are known and documented. User accounts are set up with the principle of least privilege. You have automated security scans with auditing, rotation. You're compliant with every acronym that you can be compliant with. You have alerts that you can respond to, and you don't get any false alarms at 2 a.m. There's encryption without impacting performance or velocity. Just think about that. So open your eyes and think about reality and how it currently maps to this secure paradise. So in reality, most of our systems don't map out to this paradise that we'd like to build. So we don't know what we don't know. We don't necessarily know where our secrets are, who might be using them, or who might be implementing them. You might have a new junior dev that's working on a new download service and hard coding an access key or an API key. And it's not necessarily an issue of blame or criticism. There's just some legacy systems. They're the realities of modern infrastructure or inherited infrastructure. And there were probably a lot of reasons and motivations for certain decisions. Sometimes you might not understand the decisions, and you can curse the people that left that infrastructure behind for you. But situation is, we just work with the systems where we have. We build secure systems where we can. But like a lot of operations, it's about iteration and awareness and being able to audit and review the systems that you do have in place and work with the infrastructure that you have. So from here, I'm going to talk a little bit about the anti-patterns. So one really big anti-pattern is just hard-coded secrets. And for anybody that's had to deal with a secret in Git, changing history is hard. It's kind of a pain. There's a lot you need to do to be able to actually scrub that out. And these secrets can get committed in a number of places. You could also have secrets embedded in your machine images. Has anybody run across a password stored in a wiki somewhere because maybe there was a code snippet that was pasted in? So there are a lot of places that, these secrets are just out and around in your infrastructure. Another big anti-pattern is shared or reused credentials. When someone slacked me that production key, usually if that's the path to least resistance, that's what happens. Also, there are instances where the only options are you give someone full access or you give them no access, and there's no tiering in between where people that maybe need read-only access should only get access to certain resources, or creds that are reused across environments. Also, sometimes you have that default password in your infrastructure. It's the password that if nobody's quite sure how to log into that database, there's that one password that we kind of use for everything that we all kind of know about. So that often proliferates across your environment where you'll have these known passwords, or maybe even having unsecured services because, we only need to contact that system through HTTP because we're only using it internally anyway, and there's no chance that we'll ever open up a port to access that system to the public. So, we don't really need authentication on Mongo, do we? So another anti-pattern is insecure sharing methods. So, like I mentioned, passwords getting messaged over chat or email, written on public spaces on a whiteboard somewhere, passwords that get logged in command history or saved places where they shouldn't be, like on stickies on your desktop or Post-it notes, or I've seen people have them tagged in, phone contacts or calendars or notes in other places. There are a lot of places where these secrets can get stored or shared in plain text, and you don't necessarily know what kind of visibility other people with unauthorized access are getting. Another problem, the problem of SSH keys. So once upon a time, the promise of DevOps was, you're never going to need to get to a shell prompt anymore, so you don't need these SSH keys because machines are going to do that all. So how many of you in Ops have logged directly into a box in the last week or last month? How many of you are logged in this second? And how many still get satisfaction about being able to log into a system and access it to be able to do the thing that you need? So with this, that introduces a lot of problems about how to manage these keys. Is there that jump box on the network that has all the keys to all the rest of the systems? And now everybody that has access to the system also probably has access to all those keys? So how can my systems and I keep secrets? And I say can and not should because there is no one-size cookie-cutter solution. Like I mentioned, this is just something that needs to be iterated on. There are many different strategies to be able to keep your system secure and keep your secrets secure. So I'll start with a couple public service announcements. One is it's not just the tool that you put into place. A lot of it is the process. And I'm going to be focusing a lot on principles over just the specifics of the tools. There are a lot of write-ups on tool usage and implementation, but the best tool is going to be the one that you can enforce usage of, the ones that you're actually going to use within your organization, the one that people know to use, because a well-implemented security solution isn't going to really matter if nobody's using it and if they're still following all of the same anti-patterns. Another thing, and this really relates to your personal and team secrets, is where possible, implementing multi-factor authentication as another method for being able to secure your logins to key parts of your infrastructure. So we have questions. I have questions. There are a lot of considerations when implementing a secret management solution. Everything from identifying the location for the secrets, determining how to manage and update. Another big thing is revoking these secrets. I mean, are there secrets on your network now that are still the same secrets and 5 or 50 people have left the company and they haven't really been changed, and those people probably have had access to that password at one point or another. So let's talk about some systems. Broadly, there are various different considerations. If you're in an industry that has to comply with certain standards of security, or if you have an internal security team that dictates handling and managing your data, that's a big thing. Also, just the technical requirements of your infrastructure. There's the cloud providers that you're using, whether you've got internal and external systems, and what your internal team looks like also, who's going to be managing and taking care of the system. And also looking at some of the paid tools or consulting, it's what budget do you have to actually put. The reality also is just organizations with sufficiently complicated or special infrastructure may need to build something that's slightly tailor-made using some of the tools that are out there. But I think the big point of this is that secrets isn't an afterthought. It actually should be allocated for as a feature planned and given sprint time. It's not a side consideration. It's something that has to be planned because it just doesn't happen by default. As far as looking at tools, you can build your own internally, roll out some open source tools, or I'll look at consulting to set this up, but it all just depends on the organization. In addition, looking at the tools that you have set up, it's how much access do engineers need in what sense? Is there going to be the right level of auditing to know when somebody's accessed something, when something's changed over? And if you're looking at some different open source tools, what does that community look like as far as how often it's being maintained, how often that tool is being updated? And once you do have a system that is integrated into your pipeline, things like backups and availability become really important. If having the secrets management tool is now integrated into your pipeline, you've got to make sure that doesn't go away, because that could stop you from being able to do deployments or release code, or even depending on how tightly it is integrated into your application, your app just might not run if it can't get to the secrets or credentials that are needed. Okay, so we'll look at a few different systems for managing secrets. There are, on the personal and team level, password managers. There are some different secret storage where you've got some platform-specific credential managers built into some common tools. And then you've got some of the more comprehensive secret management solutions, and some that are actually built into specific cloud providers. So starting with password managers, these are largely designed for managing human and team passwords. You don't see on there that shared Excel sheet on the network that maybe has a password that's got all of the users and credentials. These are very much designed for ease of use. Some have automation, like ePass, for example, has a command line tool that you can use to read and write secrets. Some of these don't, but they're more designed, a lot of them are designed for being UI-centered, easy to update, and also easy to share. And so some of these vary between paid and unpaid solutions. But in short, there isn't really a reason to not have some kind of centralized way for being able to manage the passwords and logins that you use among a team. Any method is more secure than no method. So going on to secret storage, this is going to be platform specific and independent on the systems and tools you have in place. They're not necessarily portable. And also, if they're related to a system that engineers have shell access to, oftentimes having access to the system is going to mean having access to the secrets that are stored in that system, because they might not necessarily be secured or beyond that. And so these tools at least solve the problem of securing credentials that live within those systems. They aren't comprehensive, and this is usually most likely going to be integrated with more of a top-level secrets management tool. Talking about Kubernetes, there's a secrets object, which basically will allow you to abstract the secret away from your definitions. They're base64 encoded, which means they are not encrypted, but they do get encrypted in etcd. And if you have access to the cluster, depending on how you have your role set up, most likely you're going to have access to this secret as well. There are some different tools that allow you to be able to read and write secrets there, but this is essentially a way to be able to start abstracting your secrets and secure creds out of your actual application definition. Pipeline tools, again, there's some different methods of being able to store secrets within different pipeline tools. I'm sure there are some that are missing here, but the other thing to take consideration is just depending on how you have these secrets listed and managed, if you have access to the actual box itself, there's a chance that you may have access to all these secrets. They may show up in your log outputs, they may show up plain text otherwise, and also if it's not integrated with an external tool, likely it's going to involve some type of manual management if you haven't integrated into any tooling or your secrets manager. But most likely, if you're managing your secrets through Jenkins, it will also be integrated with Secrets Manager with version control systems updated to the API, so there's rotation in place and so on. Another method as far as using Git is that there are some tools for being able to encrypt before it is saved into version control. This is without some overhead of setting up some scripting and integrating into your config management. This would basically most likely be integrated using a GPG key of some kind or some kind of encryption key that you get from another encryption service that will then take and encrypt secrets before they put them into Git. So at least it's kind of getting away from the problem of putting a plain text secret into your actual version control. And there's some different tools out there for being able to encrypt these secrets, but also there is just this overhead of an encryption and decryption having to happen before and after to be able to use these. As a side note, various different version control systems now have the ability to do secrets detection to kind of flag you before you actually commit something or somewhere in that process to say, like, hey, do you really want to do that? So as a note, GitHub has released GitHub Secrets, which integrate with GitHub Actions and some of the workflows to be able to plug in and identify secrets that could then be used but aren't committed in code and can be referenced using parameters and variables and so on. Looking at the config management tools, most of the ones out there do have some type of secrets management. The one thing is that, one, this will allow you to abstract any of your secure data or secrets outside of your actual playbooks or cookbooks or state files and so on. But somewhere you have to get those secrets into that config management system. So you still do have that problem of how do you manage and version the secrets that you're plugging into that system, and also if someone has access to the cluster or the tools, then you probably have access to the secrets that are listed there as well. So now going on to your actual secret management systems. So this is the latest from StackShare as of a couple days ago for the tools that are most widely in use, or the number of listed public stacks. I had originally a list of the top ranked ones, but I've found that's kind of changed week by week, and it's kind of obscure as far as how that's defined, but this is actually just the numbers. So I want to go into a little bit about what a generic secrets management pipeline might look like with the secrets management tool that you're using. One benefit is that different systems may eliminate the need to actually have credentials to certain things. It's just that the machines are now going to have access, or maybe you have token-based authentication where you don't have to see the actual secret. That's getting handled in the back end for you. Where you have secrets in code that's now substituted with a parameter, and this may now get injected by your management tool just either at build time, deploy time, or dynamically at runtime. So you'll have different impacts by some of the different methods. Of course, if the secret's injected dynamically at runtime, you're going to have encryption from end to end. The secret isn't visible or available, but then you're also going to have just this overhead now of the application is dependent on being able to access and have that secret. And as I mentioned, depending on where they are injected, they may live unencrypted somewhere along the pipeline. Like if you inject your secrets into your Kubernetes deployments in Jenkins, then if you go onto the Jenkins system, you'll probably see all of this information that's living in your configs. So it all just depends on your threat model, on the type of application that you have. It changes also if you have shipped software that is going to need to have a secret embedded. You'll just need to look at having sufficient obfuscation or encryption and so on to be able to ensure that that doesn't get leaked or discovered, because reverse engineering is a thing and secrets can be extracted from binaries that are out in the wild. So there are several open source tools that are out there. There are various tools that have been custom developed by some of the companies out there to be able to tailor into your specific system. A lot of the management tools won't lock you into a specific platform or provider because the likelihood is that you'll have a mix of hybrid environments, on-prem, cloud, pipelines that deal with different types of applications. But whichever tool is used, any of them is likely going to require some kind of learning curve or configuration or customization to be able to plug in to your existing tools and infrastructure. I'll be focusing a little bit more on Vault, as it was just as seen earlier, one of the predominant tools that's out there. But like I mentioned, it's not the only one. There are several tools that are out there that can be adapted and used for your environment. In addition to the open source tools out there, which do all have some type of, some of which do have some enterprise or paid editions or some consulting and support that's available to be able to roll them out. There are some closed source or service provider or hosted tools that are available as well. So Vault, which is pretty robust. It has a lot, has rotation and exploration built in. There's a ton of community support and documentation and integrations, a professional services team for deployment. But also there's a lot of overhead and management complexity for any that have managed Vault clusters or implemented Vault into their pipeline. When you're rolling out into production, you've got to get console and figure out your clustering, get app roles and policies, get integrations going, get configuration, and the list kind of keeps going on and on until you're in the spiral of documentation and implementation that could take you down, a far road as you're getting set up. So just a few notes. There are some Kubernetes Vault operators there and plugins. There are several integrations that are available to be able to plug into your existing version control systems, and I've included a couple notes and links as well about implementation details. And I'm not sure if I mentioned this early on. The slides will all be available as well after this talk. So I'm going to go a little bit into some of the systems that are available at the cloud provider level. I'm specifically not going to focus on any hardware security modules, HSM, as part of this talk. So we'll start here with Amazon Web Services. So Amazon, they were second most popular in the list on StackShare, and there are various tools, but once again, this is looking at mostly being platform specific. Like their secrets manager tool is pretty useful if you live within the Amazon ecosystem because it has built-in rotation for things that are part of AWS. For example, you have built-in rotation for your RDS databases so that everything is kind of controlled end-to-end. There is the certificate manager as well, and then the key management system for being able to manage your encryption keys. Google Cloud also has a new secrets manager, which was just released. This was an evolution of a tool that was out there, Burgless, which is also still available, and they also have a key management system as well for encryption keys. Azure Key Vault rolls all of these features into one service that includes secrets management, certificate management, and key management. Just another note, also, as I mentioned, Amazon and Azure do have certificate management, but Let's Encrypt, which I'm sure you've all heard of, and there's a certbot utility which can be scripted and integrated into pipelines just as far as certificate management goes for your certificates as a secret. So from here, I'll talk a little bit about addressing these anti-patterns. So fixing, I use just very, very loosely. I take kind of liberties with that. There's, like I mentioned, it's iteration. It's just kind of continually going through and improving the way that secrets are managed in the system. There are several tools out there that will scan your repos for secrets, which is good and bad, because if you have access to these tools, that means people out there in the world also have access to these tools to be able to find out whether you have secrets. There's the argument of, well, we only have a private repo. Well, can you guarantee that repo is never going to be converted to become public or open source? And also, it's not like there's necessarily auditing about the number of times that's cloned, and can you guarantee that your devs have only cloned that onto secure and encrypted local file systems on work-approved laptops, and aren't there floating out in the wild? Because once that repo has been cloned and available somewhere, then any secrets that live in that repo are now going to be wherever in the world it has been downloaded. And so another note too, just as cleanup is happening, what if changing the secret does break things? Well, that's also part of identifying all of the spaces and places that secret is referenced. So I wouldn't recommend ripping these out and changing them in prod. You'd have a dev or some other environment that you could test in advance, just to ensure that slowly these items are getting removed that are hard-coded in your systems. As far as shared credentials, role-based access wherever possible, being able to solve the problem of having more than just all access or complete access and no access. Also, there is really no reason why you should have to use the Amazon root credential or root user to log in. IAM is a good bet to be able to have actual permissioned user accounts to be able to get into your systems. Same thing with databases. And also, just as far as shared credentials go, part of it is looking at scope, because there are some secrets that are shared team secrets. Maybe you've got license limitations, so 10 people are using that admin account to a logging dashboard because it costs more money to get an individual user license. Well, that just has to be evaluated as part of the system. Is how do you deal with onboarding, offboarding, and making sure that once someone does leave, or how do you limit access when people no longer need to be able to get into a system. Fixing insecure communication. This one's kind of a challenge because it's sort of the path of least resistance. I just say secure communication channels. If something does get messaged, things going over email are generally not really a good idea. So if you do use a messaging platform and are able to share a secret and delete it, or if once a password manager is in place, most of them have provisions for being able, at least the web-based, for being able to share secrets out. There are some encrypted messaging platforms that are out there as well, or defining just maybe a secure shared location, but also just having these as temporary credentials or temporary locations, and making sure that they're removed after the fact. As far as SSH key solutions go, this kind of goes back to the shared credentials, moving towards having individual keys for users, and this is where having a good config management system, even if it's just one that you exclusively use to just push keys out to your boxes, will help for being able to do rotation when people leave. And part of this, too, is just doing auditing of any of the keys that are out there and limiting access to shared. There's some secret management solutions like Vault that does have a provision for being able to, lock up all the keys in the vault, and then based on your token, you're able to use that to authenticate as well. But there is the overhead for being able to set that up initially. So some personal and team strategies, just auditing and limiting your password usage, looking at just maybe temporary tokens or expiring tokens, auditing your root user accounts, again, using multi-factor. If you've got passwords that you've got stored plain text somewhere that are meant to be temporary, go back and clean those up. Even if you've got a secure file system, there are just methods of being able to, you just want to be able to secure the data and not have any possible avenues of being able to leak secrets. Also, just looking at your password policies. There's been a lot of talk just about rotation and expiration. 30-day expiration policies or password resets aren't necessarily a good thing. This has been kind of documented out there. It's more of just defining good policies also for offboarding and onboarding. When people start or leave the company, how do you revoke access as needed? So in closing, as I mentioned, the best system is the one that the team will use. And sometimes it's the one that is enforced by security. If there is sufficient either testing or verification in your pipeline process that enforces that secrets can't be saved, or maybe that code can't be deployed or saved with a secret available. It's just about looking at the system and seeing what works within your infrastructure, and having this process knowable and published to the team so that the team across the board has the awareness of, okay, I'm creating something or I'm building something that needs to be secured in some way, at least knowing where to go to put that information. Dynamic secrets and parameters, looking at roles and least privilege, and also just generally, as I mentioned, iterating and monitoring. It's a process, like all of operations, just continually being aware of your system, doing periodic audits and reviews, and rotating where needed if you know that a secret has possibly been compromised. So at the end, I've got a few just different links and resources which will be available in the published slides. So if you'd like to share your secrets, or your secrets management, rather, then feel free to talk to me. I mean, there was a lot of other content that I would have liked to include. One follow-up to this is just some write-ups that are going to look at a deep dive into some of the specific tools. If I missed your favorite tool, I'd love to hear about it. If you have success stories in your organization about the awesome way that you're managing and securing your systems from end to end, or if there are any horror stories about, like, oh, I hate the way that we're doing this right now, but it's the system that we got, then I'd love for you to share those as well. In short, thank you all very much, and I hope you enjoy the rest of Scale.